Welcome, my name is Brian Nelson. This is the 8th lesson in the Introduction to Programming with C# course. In this lesson, we are going to introduce the concept of variable scope, and we will take a look at access modifiers. Let's get started. Variable scope is the area of code that is able to access and interact with a variable. The first level of scope is class level scope. A variable that is defined at the class level can be accessed by any code block in that class. If the programmer exposes that variable through a property or other method, then any code that has a reference to that object is also able to access that value. If a class is defined as static and a variable is exposed through a static property, any code in the program can access that value. This is one method for creating a global variable in C#. Generally, global variables are frowned upon since values can be changed by any code in the program at any time. That being said, there are times when you want to make a value generally available to all code in a program. The second level of scope is method level. When a variable is defined at the method level, any code in that method that executes after the variable has been defined can access the value. This is also true for parameters that are passed into a method. They are available to all the code in that method. The third level of scope is block level. A variable that is defined in a branch of a conditional statement or in a loop is only accessible inside that block of code. In the case of a loop, the variable is redefined with each execution of that block. So if you wish to sum the values in an array, the definition of the variable to store the sum needs to be defined outside of the loop. So we can define variables that are accessible at the class level, the method level, or the block level, and using class level definition with static modifiers create globally accessible variables. Let's take a look at how these work in Visual Studio. Let's create a new console app for lesson 8. Get rid of that. I'm going to create a new folder. Objects. In this lesson, we're talking about scoping and access modifiers. So we're going to start with scoping. So we're going to add a class, and we're going to just call it test class. And what this will let us do is just explore some of these concepts. We're going to declare double class level equal, and we're going to set it to a value. So this is a class level variable. What this means is we have defined a variable at the class level. It is a double, and we've set it to 0. Now let's create test function. We're going to say double method level equals, we'll call it 5. Now we've defined a method level variable, and we've got a class level variable. We're going to create public void test function 2. And these are just meaningless, but they're just trying to set up some code that we can explore. And we're going to say double method 2 value equals 8. So let's define double value equals method level times class level. Now let's give this a better value, 0.5. This would come down to 2.5. So 5 times 0.5 is 2.5. Here we can see method level. We can see that variable. So that's defined at the method level. We can access the class level variable. So we can access the level up above us. Down here, double value equals, and we can do the same thing, method 2 value times class level. You can see that we can access our local method level, or we can still access the class level. But let's try to access double value 2 equals, can we access method level? Let's just copy that name. It doesn't show up. This function can't access the value defined in another function because it's not in the same scope. So that doesn't exist in the current context. In this block of code, we can't find that. So that's not going to work. The next thing we can look at is in our program, we need to add a reference to using lesson8.objects. So now we can see our test class. We'll call it TC equals new test class. Now let's try to use tc.test function. And we're going to tc.test function 2. All right, so now we can debug these. Let's go ahead and just put a breakpoint in each of these methods. And let's see how this works. So we're going to go to the first one, hit F5 to run. I'm going to run to those breakpoints. So I hit the first breakpoint and F10. So our method level is 5. And you can see if we expand this, this refers to the class, we can see the class level variable from here is 0.5. And so if we hit F10, we get a value of 2.5 like we expected. And then we'll continue, go into the next function and hit that breakpoint. We now have a value of 4. What you'll notice is if we wanted to, we can use the same variable name in both of these methods and they won't interfere. We hit F5 or rerun that. So that worked and we got a value of 2.5. And again, we get a value of 4. 8 times 0.5 is 4. What if we do double class level equals 4? Let's move that up. And this is something you don't want to do. We can redefine a local variable that hides the class level variable. Rather than ending up with 2.5, if we run this and hit F10, we're going to end up with 25. 5 times 5 versus 5 times 0.5. This is defined at the method level, and the local definition will override and hide the variable defined at the class level. Okay, so we're going to get rid of that because we don't want to do that. In this function, let's say we want to do 4, by hitting tab twice, it sets us up a basic structure here. So we're going to go from 0 to 24, so that's for the hours of the day. We're going to say double block level, and we're going to say that's equal to, we'll just say I times method level times class level. I'm going to get rid of this breakpoint. And I'm going to hit F5, and that'll run us to this breakpoint, and hit F10. We can see our method level value. In this class, it's 8. Our class level value of 0.5. And our block, we're going to calculate the block level value of 0. And now it's 4. And now it's 8. Okay, so that works. I'm going to stop this. And so down here, what if we want to use that block level value? Double value 2 equals block. Well, it doesn't show up. Let's say block level. It's saying that the block level does not exist in the current context because we're outside of the context is that block of code right there. And if we notice, if we move this into that block, it does work. It's happy with that because the variable is defined right in this block. As soon as we exit that block, it's gone. Likewise, we could double method level equals 4. Now it's unhappy. So because this is in this method, it's saying that we cannot define a local because one already exists outside of the loop. So whereas before we could override the class level, we can't overwrite the method level value, which is actually good because it means that we won't screw up our code. What we can see now is we have a block level variable, a method level variable, and a class level variable. So those are the 3 basic types of scoping that you can define for variables. So let's add a class, and we're going to call it globals. And what we're going to say is public static, and say we have public static. We're going to create a public static double, we'll call it max temperature. And you can get or set that. Okay, so we have a static property in a static class. What we might do is globals.maxTemperature equals 40 degrees Celsius. What we've done here is, because this is a static object, there's only one instance. And so this is a way of creating a global scoped variable. No matter where we are, let's add a test function 3, public void above max. And we pass in a double test value. If test value is greater than globals.maxTemperature, we're going to, let's just do a console.writeLine above. Else console.writeLine. Now what we're going to do is we're going to say tc.aboveMax, and we'll pass in a value of 50, and then we'll say tc.aboveMax, and we'll pass in a value of 40, and then we'll do tc.aboveMax and pass in a value of 30. If we run this, I'm going to get rid of this breakpoint. So we've run to the above max function, we're passing in 50. What we can see is we have access to this static property. No matter where we are in our code, we can get to globals.maxTemperature. Yes, it's above, and then we go into here, it's below. 40 is equal to, it's not greater than 40. So we go to below there, and 30 is definitely below. So that's a way of creating a global variable in C#. Basically, we have 3 different basic types. We have a class level scope, we have a method level scope, and we have a block level scope. And this could be an if, it could be a loop, it could be a do while, it could be a for. So any block of code can define variables at, so that would be at the block level. And then through the use of static classes and static values, we can create global values as well. So those are the 4 levels of scoping that we can create in C#. There are 3 types of access modifiers that we're going to go over now. The remaining access modifiers will be revisited in a future course. Access modifiers can be assigned to either classes or methods, and they define what code is allowed to reference a class or a method. They are useful when you want to create a library of code that other programmers are going to use, as they enable the developer to specify what is for public use and what is for internal use. The first access modifier is public. Public on a class means that any code can create the class. Public on a method means that any code can call the defined method. The second access modifier is private. Private means that the method is only accessible from the class that contains it. It is also possible to define private classes that only exist inside of another class. Personally, I'm not a big fan of this since I believe it hurts code maintainability, but there are cases where it can be utilized. The third access modifier is internal. Internal means that any code in the same assembly can access the class or method. An assembly is a dynamic link library or DLL or an executable. Internal comes into play when you are developing a library for use by other developers and you want to create classes or methods that are only available inside the library but not externally. As I mentioned, there are additional access modifiers possible. They are protected, protected internal, and private protected. We will come back to these access modifiers in the next course when we learn about inheritance. Let's go into Visual Studio and learn how to use the first 3 types of access modifiers. Now we're going to look at access modifiers. To do that, I'm going to add a new project. Select down here, class library.NET standard, lesson 8 library. What a library is, it's a DLL, dynamic link library, gets generated when this gets compiled. Our console app, which is a program, we can add a project reference. We can reference lesson 8 library. Lesson 8 can use functionality in the lesson 8 library. So you add a library so that you can create reusable functionality, and you can put that code in one single place. Anything that references the lesson 8 library can use that functionality. We're going to add a new class to the library. I'm going to call it test class 1. And then I'm going to create another test class. Add class test class 2. And I'm going to just set up some sample functionality here. So back in test class 1, the first access modifier we've already used, which is public. I'm going to make both of these public for now. Public string value 2. And that's going to go into test class 2. And I'm going to say public string value 1, and that's going to go into test class 1. From our program, I can comment out all this now. Let's go ahead and we are going to add a using to lesson 8 library. So now we can reference these two classes. So test class 1 equals new test class 1. And test class 2 equals new test class 2. We can go ahead and run that. We won't get any errors. Okay, exited with 0. 0 is good. So we're done. Let me close that one. We got test class 1, test class 2. I'm going to close our globals and back to our program. So that's a public string. Okay, and we can see how we can use that. So we can say 1.value1 equals test value 1. 2.value2 equals test value 2. Those are set. Basically, in each of these classes, we have a public access modifier for test class 1. That means it's generally available by all code. And we have a public property. Our second access level is private. And so let's make a private string. I'm going to call it private value. And we're going to say get set. And if we go back, so we can say 1 dot, and you notice there is no private value in that list. If we try to use it, equals test, it's saying private 1 is inaccessible due to protection level. So what we've done is we've set the protection level of private value to private. When we define private at this point, we say that the get and set are private. We could make them both public, so now they're both public, and we can also just say private. And so if we were to go ahead and create a constructor now and make that constructor public, we can say private value equal set in constructor. Now we can't set it, but what we can do is say console.writeLine 1 private value. And if we run this, and we're going to stop right there, we can see that we can access the private value, and we were able to print it out. You can make just the getter or the setter private. Let's go take it back. If we make this all private. Now it's unhappy with us because we cannot access it. So I'm going to comment this line out. We're going to run into this constructor here, and I'm going to put the breakpoint at the end. Private access modifiers mean that only the class can access it. So a private is only accessible in the class that it's defined in. So let's go to test class 2. What if we make this private? you get a couple of different errors. It's unhappy because by defining a class like this as private means that nothing can access it. And you'll also notice back in our program, we've got a bunch of errors in here because they're private now and it can't access them. If we make this public, what you could do, hidden class, private class, where you can create private classes is inside of another class. So we've defined a hidden class inside of test class 2. And so how we could use that is if we create a constructor here for test class 2, we can say we can create an instance variable for that at the module level called hidden class, and we're going to call it underscore hidden. Hidden equals new hidden class, and then we can say hidden dot hidden value. What we can see is that by defining a private class inside of another class, we hide its existence from anything. If we were to come back to the program, it doesn't show us that class. And so let's just copy that name, go back to the program. What it says is it just doesn't show up externally. So that won't work. And it will only work inside of this class. Now, how would you use this? I mean, if you need a data structure and you want it to be only visible internally to this class, that's why you would do this. In our temperature examples, we could have the temperatures in a hidden class and only use them internally and not make them available publicly. So now we've gone through public access modifiers and private access modifiers. The third type is internal. I'm going to create another class, add class, test class 3. First, I'm going to start it as public. I'm going to create a internal string name. So what I've created is a name property on the test class 3. We'll go back to our program. Test class 3 equal new test class 3. 3 dot. We don't see anything because the name is internal. Now, like we said before, we could make this public and this be internal. 3 dot. We can see in here that the name is available. Okay, and so if we were to write that console.writeLine, and we have to give it a value. So if we go into our constructor, or we create a constructor, name equals set name. Go back to our program. Let's move our breakpoint down, and we can run. And we don't need that breakpoint right now, so we'll clear that and hit continue. We can now see that we're able to access it, but we can't set it, and we were able to access it. We can also make the entire class internal. By doing that, if we go back to the program, it's now upset because we can't access it here. So I'm going to comment this out. What I can do is if we go into test class 2, test class 2 exists inside the library. So inside the library, we can now test class 3 equals new internal means that only things internal to this assembly or DLL or app can utilize that functionality. So if we go ahead and run, and we're going to put a breakpoint here inside test class 2. And so if we run that, we can now see that test class 2 has full capability of using the internal class. That defines public, we've got private, and now internal. So those 3 different levels of access modifiers are what we have available to us. That wraps up our 8th lesson. In the next lesson, we will investigate a few useful functions built into the .NET library.